The second false assumption is science works, therefore its conclusions are true. Science works, guys, therefore its conclusions are true. Well, that's not true. Let me explain. If we study the history of science, you will see that there were theories that were working, that provided things that we now call truths, but we eventually found out that those theories are false. For example, in the 1700s, there was this workable theory called the theory of phlogiston. Okay? The theory of phlogiston. What was this theory? If things were combustible, they could burn, they would release phlogisticated air. Dan Rutherford in 1772, he used this workable theory and he discovered nitrogen. Nitrogen. But after a few more years, they found out that the theory itself was false. This shows us that you can get a truth from a workable theory that's eventually found to be false. So there you go. It's not true that just because science works, it must be true. That is a false assumption. You have the philosopher Samir Okasha in his book Philosophy of Science. He says historically there are many cases of theories that we now believe to be false, but that were empirically quite successful. Also you have Professor Elliot Sober. He says false models can sometimes work better than true ones. So the second assumption that science works, therefore it's true, is a false assumption.
Science works, its conclusions are true. Okay. So this is a really interesting contention. Something working is equated to truth, right? So science works, therefore it's true. And this is really summarized in a nice conversation, not nice, but funny conversation that happened between Richard Dawkins, and with him was the philosopher Stephen Law, and this is available on YouTube, in which they have this discussion. So if you just put in Stephen Law, Richard Dawkins, you can watch the entire lecture. So in the lecture, somebody asks a really profound question. Someone says, and they bring up this ancient problem which David Hume pointed out, which is known as the problem of induction, which is that if you have, say, observations of 100 sheep which are white, you say, based upon my observations that there's 100 white sheep, all sheep are white, or the next sheep which I'm going to see is white. So you're using a limited set of observations to make a general conclusion. David Hume rightly pointed out that actually you can't really say that with certainty, because in the future you may come across a black sheep. This is the problem of induction, or the black swan problem as it's otherwise known. This particular problem is a very serious philosophical problem, and because people don't understand the difference between popularizers like Richard Dawkins, who's not a philosopher, and academics who actually study this stuff, they just look up to him as if he knows. So anyway, in this interview that was happening between Lawrence Krauss and Richard Dawkins, they were taking questions and answers from the audience. And somebody in the audience asked, how do you justify the scientific method? Because the theories that you have, you can always get new observations which can challenge the old theories. So Richard Dawkins, in his very stylish sort of way, and being very, naive, he says, science works. Rockets fly, medicine works, this, science works, therefore it's true. And then he adds on, science works, bitches, and everyone starts clapping, right? It's a really stupid video, because he thinks he's got this energy, this profound status that I can just say this in public. I can call everyone in the room a certain expletive, and everyone's going to clap, and they did, because they're like penguins. So Stephen Law, under his breath, because he doesn't want to correct his Richard Dawkins, under his breath he goes, well, that's induction. But then he moved on, because he was asked, how do you justify induction? And he said, using induction, which is circular reasoning. So he was asked, science can work because you have you're assuming the future is going to be like the past, but you can always come up with new observations which can challenge it. And what he basically said is, it works because it works, essentially. But what I found interesting in that video is this. Stephen Law is a philosopher and an academic, and he understands the problem of induction, and he knows that what Richard Dawkins said there was absolute bull. Yeah. Total nonsense. But he did not correct him. He just murmured, that's induction. And Richard Dawkins didn't even notice. And he just moved on swiftly. Which goes to show you they have a public image. They want to create this image about certain personalities. They're infallible, you know, like the imams of some sort, right? There's some sort of infallible imams, right? Now, they want to create this impression, but anybody with 2 brain cells will realize, no, this is not right. I mean, you don't even need to have 2 brain cells technically, but you could be an amoeba. You'd realize actually the problem of induction is not going to be solved, and it hasn't been solved for the last 300 years since David Hume actually raised it, just because a public figure says it works. Right. And if you pick up any basic book on the philosophy of science, it's going to say something like this. This is an Oxford University publication. Historically, there are many cases of theories that we now believe to be false, but that were empirically quite successful. So they worked really well, but they turned out to be false. This is not unknown. This is not something weird. This is not, you know, we're not bringing up some sort of crazy opinion, minority opinion amongst philosophers. Philosophy of science is a very deep field, but there is something that they do agree about, which is that the problem of induction is real, and therefore scientific conclusions cannot be written in stone. Also, Evidence in Evolution by the philosopher of biology Elliot Sober. This is a Cambridge University publication. He says false models can sometimes work better than true ones. But then you'll be like, how do you know what the true ones are? Well, they're the ones that haven't been proven false yet. So it's actually really difficult. It's actually really difficult to put up an argument that because it works is true. So let me try and give you some live examples. So you have, yeah, I'll give you high fives as well. That means I've got 10 minutes left. So you have live examples in front of us, in front of our very eyes. Imagine there's somebody driving a really nice car. I don't know the names of cars because I don't drive, but he's driving a really nice car, one of the cars from like Fast and the Furious or whatever. I don't watch that film, but still. And he has nitrogen boosters. And he's going really fast with these nitrogen boosters, right? And he's full of energy. He's like, this is amazing. Science has given us this amazing thing, nitrogen boosters. And, you know, you knock on his window and he puts the window down and you basically say to him, you know, I heard what you said, you know, you're driving this car, you have these nitrogen boosters, but let me just give you the history of how nitrogen was discovered. Nitrogen is an element and it's real, but it was discovered using a theory in chemistry known as phlogiston, which turned out to be a completely false theory. But that false theory helped us discover nitrogen, which is real. So a false theory can bring about knowledge of things which we can observe today. Likewise, if you existed, say 300 years ago, around the time of Newton, and you were to look at the change the Newtonian model brought to the world, you were just to like sit there on a chair on Mars and watch all over the world the scientists that were impacted by Newtonian mechanics. You were to watch all of the extensive advancements that were made in physics and all of the achievements that were made. 250 years you would observe a model that worked really well, the Newtonian model, to the point that if you were to make a prediction, where is this planet going to be in 6 months' time from now, and calculate that using the Newtonian model, it would be there, exactly there. It worked well for 250 years. Einstein came along and showed it was false. Time and space, according to the Newtonian model, is fixed. Einstein came along and said it's actually like fabric. According to the Newtonian model, gravity pulls. Einstein inverted that and said actually space-time curvature pushes down, so it's a pushing thing. Einstein came along and he changed even the definition of mass that was being used in those calculations, which were working perfectly. So 250 years, the best scientific model you can argue in our history that's worked amongst the most successful of theories, but the most successful you can easily argue is Newtonian mechanics, Newtonian model, and it turned out to be false. But it gave us a whole bunch of new information. So just because something works doesn't mean it's true. If you were to walk into any university in the world, and it's a challenge, any university in the world, and you were to walk into the physics department if they had one, and you were to ask the physicists, ask the professors, ask the research associates, guys, do you believe in general relativity? What are they going to say? Yes. Do you believe in quantum mechanics? What are they going to say?
Yes.
Yes. These two theories, which are held by consensus in physics, contradict each other. They both can't be true. Not only do we have examples in history, we have examples live today of consensus, of ijma, of physicists who believe in this and believe in that, but they both fundamentally can't be true. Yes?
Could you repeat the two things you said?
Quantum mechanics, general relativity. Einstein's general relativity and Niels Bohr's quantum mechanics. Okay? So science leading to truth because it works is not something which you can actually argue for. We just covered that. Science leads to certainty. Another publication, Philosophy of Science, a new introduction by Gillian Barker and Philip Kitcher. Same thing, science is revisable. Look at this. Hence to talk about scientific proof is dangerous. We use the word scientific proof all the time, but we're saying is to use that word is dangerous because it fosters the idea that conclusions are graven in stone.
Hamza, Suboor. Funny thing, you mentioned scientific truths can be written in stone, can't be written in stone. So actually, they can only be written with a pencil, so you can erase it afterwards.
Yes, definitely. Write in pencil because you're going to have to rub it out.
Yeah, afterwards.
Scientific theories can only be proven false. If a theory claims that something will be observed under certain conditions and is not observed, then the theory is proven false. All birds that die on a Friday, will do so in mid-flight. The old model of philosophy of science was falsification, that you can prove theories false. But the new model, which is scientific holism, you can even revive dead theories. Right? So the latest that we know is whether you believe in this old model or you believe in the new model or you believe in what's known as scientific realism, which we can cover in the Q&A, or scientific anti-realism, whatever view of science you hold as a philosopher of science, whatever it is, one thing no one disagrees about is that scientific conclusions are not written in stone. Again, science is dynamic. If you look at the history of science over the last 300 years, chemistry, physics, biology, every single subfield of those sciences, over a longer period of time, you're going to see that actually they go through massive revolutions. They go through massive changes. Okay. A contention is brought up by some people, which can be brought up by some people, which is about scientific, induction and Islamic sources. So what they say is, because you're attacking induction, you're going to be attacking Islamic sources. The first reply is, we're not attacking induction. We're merely showing this is the academic understanding of induction. Induction is limited observations, general conclusion. Right? Now, inductive arguments is where you go from a limited set of observations to a general conclusion. And they're basically saying, don't you have induction in your isnad, in your collection of narrations? The way we got the Quran, the way we got narrations of the Prophet, peace be upon him. So, Islamic sources and induction, is it a contradiction? This is a false contention, because with induction, with inductive arguments, what are you basically doing? You're basically saying, I have observed 100 sheep which are white, therefore all sheep are white. You are adding a new claim of knowledge. in our isnad, in our traditions, we are not adding. So we're not saying Ibn Abbas said Qul huwallahu ahad and therefore wal asr. We're not making a jump. We are merely mirroring. We are saying he said this and he said this and he said this. So this is inductive reasoning, not inductive argumentation. Yes, Ibrahim.
But someone might say, for instance, that if you look at the isnad of the hadith, they say that they take the knowledge from this person, or they take narration from this person because no one witnessed the life from him, and therefore he's truthful. But isn't that kind of inductive as well? Because only a certain number of people witnessed him, and maybe there are others who could have witnessed against him.
That's a very good point. And that is something which can be addressed by looking at testimony. What is valid and invalid testimony? Because this is a bit of a cross between induction and testimony. Because testimonial truths is a separate source of knowledge to induction. Some of you can cover a bit more detail in the Q&A, but this is basically linked to testimony and the epistemology of testimony. So the science of epistemology, sorry, not the science, the epistemology of testimony, we have to basically look into what is valid sources of knowledge, what is not valid sources of knowledge. How do you decide what is these particular sources of knowledge, and how do we know that, okay, we can trust these and we can use these sources of testimony to reject these? Because you might get counter testimonies. But this is a deeper topic within the epistemology of knowledge, right? So I don't want to delve into that, because we're getting away from the philosophy of science going into epistemology here. But that's the way I would address it. You just go down the route of testimony, explaining what is valid and what is invalid.